Welcome to the video, just to go over a couple more examples for angle relationships. So the examples in this video are pretty much going to be asking the same thing to find each missing measure. It's just going to be changing what information you are given. So this particular diagram is two lines. They are intersecting, which tells me that I have vertical pairs. I've got vertical lines here. So the reason why I'm going like this across the angle, or across the intersection, is because those are my vertical pairs, which are congruent. Same thing in this direction. They are opposite angles, so they are vertical angles, and they are congruent, which means they are the same measure. Now, if we look at our two choices here, this vertical angle, well, that's good. So if this is 74 over here, then I know that Z also has to equal 74. So Z is also 74 degrees. But if I look going up and down vertically here, 3x minus 5 degrees and then y degrees, I can't set those two equal to each other with any hope of solving. There's not enough information. So vertical angles is not going to be the relationship that helps me here. The other nice thing about these diagrams where it's just two intersecting lines is that that's exactly what we have here, are two intersecting lines. So that means that this angle measure here, the whole thing is 180 degrees, the whole thing, including the 74. So I could say 74 plus angle Y is equal to 180. I could subtract 74 from both sides and quickly find out that Y equals 106 degrees. So Y is 106 degrees, and that's what helps me then with this vertical relationship, because now I can say that 3x minus 5 also equals 106 degrees. I can add 5 to both sides, and I'm not sure this is going to work out evenly here. Let's check. 111, oh, it should. So then x equals 37. So x equals 37, which is not an angle measure. So let's be clear here that the 106, I did put a degree on because the y is an actual angle measure. But in the x section here, the x is just part of this. So I need to do some work here first, where I take 3 times 37 and subtract 5 to find that actual angle measure. And I'm only going to do this because it should be 106, guys. That's the whole vertical angle relationship. But I want to do it just to make sure that that it does actually equal the 106. So 3 times 37 is 111, and I subtract 5, and there's the 106 degrees. So 106 degrees up there, 106 degrees down here, 74 on the right, 74 on the left. So two relationships that I used here, vertical angles. Actually, I used vertical angles twice, but in the middle there, we actually had to use the fact that we have supplementary, the linear pair, to add to equal 180 degrees. In the second example, it's a little flipped around, but there is a box, a square marking in here notating that this is 90 degrees. So these two angles are complementary. So I know that they add to equal 90. So that's what I'm going to do. I'm going to set it up by adding the 4x minus 1. Let me move over the 1. 4x minus 1 plus x plus 3. Those two angles added together equal 90. So going ahead and solving this, simplifying, 4x plus x is going to be 5x. Negative 1 plus 3 is going to be plus 2. So 5x subtracting 2 from both sides equals 88. This is not going to go in evenly. Let's see what sort of fraction we're going to get here. Since it is dividing by 5, it's a nice terminating decimal, so I'm just going to go ahead and leave that as 17.6. So x equals 17.6, but to actually find the angle measures in there, which is what the question is asking, finding each missing measure, I'm going to go ahead and plug the x in to both of those. So 4 times 17.6 minus 1, don't forget the point there, and then 17.6 plus 3. So it definitely looks like we're going to have decimal answers for both of those. So up top here, the 4 times 17.6 minus 1 is going to be 69.4 degrees. 17.6 plus 3 will be 20.6 degrees. And the one thing I will do is just quickly come off to the side here and just do like a check that 69.4 plus 20.6 does actually equal 90. And you just want to know, guys, that I'm just sitting here using my calculator also. I'm not, doing a lot of these in my head. I'm just not showing, I'm just writing down what is going in the calculator. So use the calculator to double check that 69.4 plus 20.6 does actually equal 90 degrees. And that's just a check. My answers are the 69.4 and the 20.6. This example is using a linear pair for two supplementary angles, which means that they add to equal 180 degrees because they are creating a line. So 2x minus 3 plus 3x plus 7 equals 180 degrees. So combining like terms, 5x plus 4 equals 180. So subtracting 4 from both sides, 5x equals 176. And it looks like we're going to get another decimal here, dividing by 5. X equals 35.2. Again, plugging that in to where our x is actually supposed to be to find the angle measures is our last step. If we were just supposed to find the value for x, we would be done, but we should actually be figuring out the angle measures here. So I'm going to start over here on the left. 2 times 35.2 minus 3 should give us 67.4 degrees. And at this point, I really could just take 180 and subtract 67.4 to figure out what that missing angle measure on the right should be. But I want to make sure that I did the 35.2 correctly, and then everything is going to work out using the 35.2. So I'm going to use the 3 times 35.2 and then add 7 to get 112.6 degrees. And again, in my calculator here, I will do the 180 minus 67.4 down at the bottom, if I can, and I get the same answer, 112.6 degrees. This final example here is a little bit of a doozy because we've got a couple of things going on. What I really see are 2 intersecting lines. These 2 intersecting lines give me some relationship with vertical angles, but then I do have this ray sticking out here that does not extend in this direction, so it's not a line, it's just a ray out here, which does interfere with some of our vertical angles. So I'm gonna do some highlighting here real quick. So if I highlight these 2 lines that are intersecting, it does set up my vertical angles. So there's my vertical angles, those are opposite. So they're opposite angles, they are vertical, which means they are congruent. So 8x equals 120. And I'm just leaving this in a highlighter pen right now because I'm just kind of evaluating my choices. The other choice I have is this line that I have a linear pair on this side where the 5x minus 15 plus the 8x, because they are a linear pair which are supplementary, to add those together to equal 180. The only thing I'm not going to be able to use here is that 2x minus 5. The 2x minus 5 is useless because it is adjacent, but adjacent doesn't tell me any relationship as far as a value. I know nothing about complementary angles. There's no line here because it's off of this ray. So the 2x minus 5 I'm not going to be able to do anything with until I know what x is using one of these other relationships. Now, there is no right or wrong way to do this. I could do what's in green first to find x, or I could do what's in red. Hopefully you guys can see that this green is much longer. Not harder, it's just longer. This problem down here is short. It's going to be 1 step to solve for x. So I am going to go ahead and delete that, and I'm going to focus on this vertical angle relationship there, where 8x equals 120. I will divide both sides by 8 to see that x equals 15. Now that is not an angle measure, that's just a value for x. So I can come over and plug the 15, oops, not 5x, 15, plug the 15 in for x, and then subtract 15 I could double check that 8 times 15 does actually equal 120. I am going to want to do that. And then 2 times 15 minus 5. I'm going to want to make sure that everything is working out to be, like what needs to be congruent should be congruent. What needs to be linear to add to 180 should be linear. And we will also have to find the measure of this angle over here also, though it's not labeled. We want to make sure it is technically missing. We want to make sure we find that. So let's go ahead and do these little calculations. All right, so 5 times 15 minus 15 is going to be 60 degrees, which does make sense because this is 120. So if I add the 60 plus 120, that equals 180. So that's just a little check for me. That's not doing anything with that. 2 times 15 is 30 minus 5. That's going to be 25 degrees here. So I am going to have to do a little bit of extra math to figure out this missing angle. And I'm going to use the fact that these three here create a line. So I can take 120 plus 25 to get 145. Then I'm going to take that out of 180 to get 35 degrees. So this is going to be 35 degrees in here. So my final answer, let's see if I can clearly figure these out. 120 is already there. 60 is over here. 120, 25, and 35 are the measures for my 1, 2, 3, 4, 5 different angles. So that one had a lot going on, but you just had variety, you had choices in how you wanted to set it up. All of the answers should be the same. There's just a couple different ways you could have gone about calculating those, but just realize that 2x minus 5 was useless until the very end where we already had x. We had to use either the vertical or the linear pair to actually find the value of x first. Thanks for watching.